So the topic is topographic surveying. There's no problem solving here, just concepts and maps. So first, let's define topographic survey is a survey made to secure important data from which a topographic map could be made. So that means getting control points, getting distance measurements, elevations, and such. So to be more specific, scheme of work of a topographic survey includes the following. First, establishment of a horizontal control by measuring angular and linear measurements of a central point. So that's what we did earlier. Horizontal controls are like guide points used for construction. Number two, establishment of the vertical control by determining the elevation of control points by leveling or using plane table. So this is one of your earlier field works where we got elevations of certain points. So that's also used in topographic surveying. Next, number three, determining the elevations and locations of some important features as many deemed necessary for the preparation of the topographic map. Important features such as valleys, ridges, bridges, summits, if any, and roads are some important features in a topographic map. Number four, computations of elevations, distances, and angles as obtained from the previous fieldwork undertaken. So you've been doing this in your fieldworks, or you've been watching the demo videos undertaking these things. And then lastly, the preparation of the topographic map, or a topographic map is actually a representation of terrestrial relief as well. And relief means configuration of the Earth's surface. So that's the purpose of topographic surveying, to create a representation of the surface of the Earth. So for a certain area. So before we continue, let's have a few more definitions. Contour, it's an imaginary line of constant elevation on the ground surface. And then, form lines and contour lines. So form lines are like contours, but they represent features that are not actually surveyed, and they are shown by broken lines. And the difference from contour line is that contour line are solid lines, and they are joining points of the same elevation. Later on, we have a figure for contour lines and form lines. And then we have something called a contour interval. So on a given map, successive contour lines represent elevations which differ by a fixed vertical distance called contour interval. Then we also have hatchers. These are artificial shade lines drawn in the direction of steepest slope for purpose of representing relief. And then saddle, it's at the at the junction of two ridges. And talwegs, which are lines where two sides of a valley meet. So those are some words that you might encounter in studying topographic surveying. Now we've mentioned relief, which is again configuration of the Earth's surface. So there are several ways to show relief. One is using relief models, which are 3D representations of the Earth's surface, as you can see here. And as you can see, they're 3D. Another is by shading. Okay, so the darker shades represent steeper elevations, while lighter shades represent higher elevations. So we also have certain gradation and legends over here. Next, we have hatcher lines. As you can see, these are your hatcher lines, and they go towards the steeper elevation. So remember, there was a mention of contour interval. Yeah. So these are elevations by fixed interval. For example, here, okay, 1 to 60 represents the height of this line, contour line. So all points on this line have the same elevation of 1 to 60. Same thing here. This 1 to 80 represents the height of all of these points, and then 1,300, all of these. And as you can see, contour interval is when they are uniform. So for example, the height difference of these two lines are 20 meters, and then these two are also 20 meters. So the contour interval for this figure is 20. Okay, so that's what contour interval is. And then form lines, as you can see, they are broken lines. So they don't actually represent contour. They are just added information in the form of broken lines. Sometimes contour lines also form details of a map that are not shown or are not measured during surveying. And then finally, direction of steepest slope. So steepest slope, meaning this is towards the center because it's from top to bottom. So you can imagine the slope as from, this is the median area going downward. So that's why it's steeper going down. So that's why the lines are going downward. Okay. Yun. All right. And then finally, another way to show relief is by contour lines, which is what we usually use. This is the example of a contour line, yeah, the one on the bottom. And this is what the 3D of that will look like. Okay. So as you can see, here at the top is the highest point, and then everything in between or after that goes downward. I have another picture to show that. You might see this around. This circulated Facebook a while back, but this is another way to read contour lines on a map. So again, all of these lines are contour lines. They represent same elevation. We have a line here and a line here, meaning there's a summit over here and another summit over here, which is true. If you use the 2D, or if you look at this contour front view, this is what that will look like. So as you can see, this is the topmost part over here, and this is over here. And then here, you have this small circle, which means that's a very small area at the top, which is true when you look at it from the front. And then it gets lower elevation and larger area as you go towards the bottom. Another thing here, so this contour of same elevation, so it's a bit wide, which is, if you look in 2D, also a bit wide. Same thing on the right side. And then we have something like this. Again, highest point. So highest point here. And then, as you can see, these lines kind of go farther away from each other. So that means here, there is a steep slope. The closer the lines are, the steeper the slope is, which is true if you look at the drawing. And the farther away they are, the gentler the slope is, which is true. As you can see at the bottom, they're very far away. And there's very little change in slope. And then here, again, a very wide circle, which creates a very wide area here. And then steep on the right side. So it's steep, as you can see. Greater distances, gentler slopes. And then this almost looks the same, which if you look in 2D also kind of looks the same. So that's how you read topographic maps. Now, as I mentioned earlier, there are some characteristics to these lines. So let's talk about it. And so characteristics of contour. So characteristic number 1, all points on the same contour have the same elevation. So for example here, all lines or all points on this line are 1260, all points on this line have the elevation 1280. Same thing here. And So all points on this line are same elevation, and all points on this line are at the lowest elevation. Next. Every contour closes upon itself either within or outside the limits of the map. Okay, for example here, closes on itself. So yeah, you can see your closed contour lines. And then sometimes it closes away from the map. So it's out of the bounds of the area of coverage of your map. So that could be represented as well. Number 3, on uniform slopes, the contour lines are spaced uniformly. For example, here, yeah, these are uniform slope. As you can see, they change by 2 meters. So contour interval of this is 2 as well. Since uniform slopes, the contour lines are spaced a bit uniformly as well. So there's no steeper side or gentler side. Next, a single contour cannot lie between 2 contour lines of higher or lower elevation. So for example, here, we start at 10, 12, 14, 16, 18. There can't be a 10 between 12 and 14. Okay. For example, if there's something lower here, it suddenly dips, you can't draw a 10-meter line here. Okay. So a single contour cannot lie between those. Okay. Number 5, along plane surfaces, such as those of railroad cut-in fields, the contour lines are straight and parallel to one another. I don't think I have an example for that. Oh, let's draw instead. Okay. So for a road, as mentioned, contour lines are straight and parallel. So let's say you have a road running through here. So of course they have the same elevation. So they're just gonna be straight lines that are also parallel, since again they're all the same. And then cut and fill. So there's gonna be a cut here where you cut through the mountain, and then fill here where it goes upward. So those aren't straight lines anymore. It's gonna look something like this. And so these are the contours of the sides of your mountains now. And this is your road. So this is going upward, and this is going downward. So if you look at it, it's gonna look that way. Road, and then downward again. Okay. Next, as contour lines represent level lines, they are perpendicular to the line of steepest slope, and they are perpendicular to the ridge and valley lines where they cross such lines. So for example here, yeah, valley. Okay. So valleys look like this. Okay. Yeah. Valley. Something like that. So straight or landing over here, then go steep downward. So it's stated there, contour lines are perpendicular to the steepest slope. For example, here, the steepest slope is this line, okay? And our contour lines are parallel to that line. So this dotted line represents the steepest slope. That's also an example of a form line. As you can see, these are broken lines. So as mentioned, we don't actually measure, or contour lines don't really show the steepest slope. To show what the steepest slope is, you can use your form line. So these provide additional information in your maps. And another thing, for a valley, for steeper, or the contour lines are perpendicular to the steepest slope. And then number 7, on steep slopes, contours are closely spaced, and then on gentle slopes, contours are spaced far apart. As I've shown earlier, for steeper slopes, as you can see, they're more tightly spaced. For example, here, steep here, so more tightly spaced, and then as gentler the slope gets, the farther away they are from one another. And then, as contour lines represent contours of different elevation on the ground, they do not merge or cross one another on the map, except in cases where there is an overhanging cliff or cave or bridge abutment. So for example, if you've seen topographic maps, there's no lines that cross because each line represents a different elevation. So if you have crossing lines, that means two elevations meet, which shouldn't be the case. So that's why it's very rare to see that. Again, with the exception of bridges. So for example, here we have this bridge, right? And then there is terrain below that. So if you draw the terrain, there's gonna be something like this. Yeah, so they cross. And join and merge. So you have a terrain here and then your bridge. So as you can see, there are crossing lines. So this is the exception to that rule. Okay. Next. Nine. A close contour indicates either a summit or depression. A hatchered closed contour line indicates a depression. So for example here, you have hatcher lines, and this is a depression. It gets lower as you get more to the center. So if you try to look at that 3D, that's a depression, meaning there's like a hole on the ground. So there's the presence of a hatcher line, which also indicates a depression. Other examples, so yeah. A depression doesn't always have to have hatcher lines, okay? For example, here, yeah, this is also a depression just by looking at the values 18 on the outer ring, 10 on the inner ring. So at the very center is the lowest point. So again, that looks like a depression or a hole on the ground. Summit, you get higher as you go towards the center. So as you can see, elevation 10 towards 18. So 18 highest elevation. This is an example of a summit. And these are all summits. And your closed circles at the very center are these summits. Or closed contours at the center of each map are these summits on your area. And the next, as contour lines, next. A contour never splits because that means there's a sudden stop in elevation, which doesn't happen. So contour never splits, and then no two contours can run into one. Because again, each contour line represents a different elevation, so they shouldn't merge into a single elevation. Okay, so that's the characteristics. And then finally, we have the five different types of, or five common types of ground formation. Again, we already know the depression and summit. And then we have the end of a ridge and end of a valley. Let's try to show the difference between the two. Oh, there's a question. Paano malalaman yung value ng elevation per contour line? It's specified. It's either by a number or by shading. And then you're just going to give a legend to the colors of your shades. So in our example, yeah, it should look like this. As you can see, there's always values for each contour line. And that's how you know it's elevation. And their values are taken by using your surveying methods, your leveling, or you can use GPS, you can use plane table surveying. So the things we discussed previously are the ways to get these values. Okay? Okay, so valleys and ridges. And so they kind of look the same, right? End of a ridge, end of a valley. But if you look at it like an actual example, this is a ridge. So there's the same elevation on the top, which has sloping sides. Okay? And then this is a valley. So for a valley, on the other side of this doesn't have to be another slope. So this could be continuous, but a valley is just a U or V shape in between two landscapes. Okay, this is your valley. This is a ridge. So that's the difference. And their ends look the same. And ends of valley and end of a ridge because it comes from a higher elevation to a lower elevation. Okay? And then finally, saddle. We've already discussed what saddle is. It's a dip at the junction of two ridges. So there's a ridge here, a ridge, ridge, ridge. So this is a saddle where the ends of a ridge meet. And that's it for your contour lines and topographic surveying. Do you have any more questions? Okay. All right, once again, coverage of your exam is stadia theory, triangulation, topography, general characteristics of contours. So since you don't have any more questions, you may go. See you on Saturday. Goodbye, class.
Thank you, ma'am.
Thank you po, ma'am.
Ma'am.
Thank you po, ma'am.